All right. So the next thing that we're going to see is our studio. On this side of the screen, you can see what our studio looks like. I'll just try to, yeah. All right. So here's where you write the code. I've written the code here, and this is the console, and you run it here. This is the visualization tab. Okay. And here you can see all the variables if you declare any. What this question I've done here, okay, I'll just talk about the simulation I'm trying to run here. The simulation is about if you enter a room, and so if 10 people enter the room and they all have hats, and they put the hats in near the door, and when they get out, when the party is over, they want to get out, but they're not conscious enough to pick the right hat. So what is the probability that at least one of them picks the right hat, right? So this is a simulation for that. You set the seed. Now we'll be looking at in the sampling part of the video what setting a seed is. So that's basically so whenever we generate a random number, it's called pseudo random because it depends on the seed value that we feed. So setting the seed also helps us to reproduce the same randomness again. So if I read on an experiment, if I have set the seed once, I can get the same outputs out of a random value. So the number of samples is 100. Number of people that are trying to grab their hats is 5. Vectors for number of matches, so just to count number of matches that are there. This is just another vector that counts from 1 to n. And the for loop where we start. So the first thing that we do is we create a vector of the random hats in the ith sample that can be picked. And we check that is either of these hats that we had initially, that these are the original hats like 1 to n, and now the number of hats that are picked could be n, right? So if any one of them matches the person's hat, then we add the sum, right? So um yeah, so basically that's all we do. And then we write here, we want to say that, okay, what is the probability that nobody picks the right one? So this is the mean of x is equal to 0 in um, that's x is the vector in which the number of matches are stored, right? So the number of samples in which x is 0 is calculated here, and similarly till 5, and then about plot is plotted. Here you'd see that there are a few different arguments that are added. The first one is a y label, an x label that is there, and you can always get these from the documentations, right? So this is what bar plot and y label are. Now let's get back to our studio. Okay, to the slide here. Perfect. All right, sampling in R. So sometimes you will want to implement a statistical procedure that requires random number generation or sampling. That's what we were doing here. We had a random number of hats generated each time that a person wanted to pick. Other times you just want to simulate a system that needs random numbers as inputs. Well, R is here to help you. So there are a lot of commonly used random number generations in R, which we'll be looking at next, right here. So we'll talk about them. First of all, there is a function called sample, which generates these random numbers. And let's just talk about the parameters or the arguments that you need to feed. X is the vector of one or more elements. Size is the number of items you want to choose. So it's more like a permutation that you do, that you have given 10 items and you want to choose 3 of them. So you provide the vector and then you choose the number of items you want. Replace is like, do you want sampling with or without replacement? Now you should be aware that if you want, if you're looking at like the best example is if you're given a 52, like a deck of 52 cards. So whenever you try to find the probability that there will be 2 hearts will depend that if I'm putting the card back in. So I take the first card out, I get a heart, get a king of hearts. All right, so that's the probability is 1 by 52. But now if I'm saying that what is the probability that I'll get 2 king of hearts? So I pick a card, so that is 1 by 52 probability that it will be a king of hearts. Now, if I do not place it back in, then to get another king of hearts, the probability will be 1 by 51. Oh, sorry, you cannot get two king of hearts. I meant if you want to get kings. Sorry, it's not king of hearts. It's two kings. So the first time the probability is 4 by 52. Now that is the king of hearts. I just put it aside. Now I have three hearts in the deck of 51. So the probability of getting another king is 3 by 51 if I did not put that card back in. But if I had put that card back in, then it would have been 4 by 52 times 4 by 52 because the probability would still be the same to get a king, right? So that's what you do with replacement. And probability is the vector of probability weights for obtaining elements from the vector. So it's just majorly giving a weight to a different distribution. So if I'm saying that uh, if I have a die or if I have a coin which gives me heads or tails, right? Um, then usually it's just like, 50-50, like either I get a head, I get a tail. What if there is some way I manipulate the coin and now I have I can get with a like chance of 60% I get a head, then 40% I get a tails, right? So for that, those weightages, we add the probability right here. So this is an example where we have to sample outputs for rolling a die 10 times. So we have the vector and we sample it 10 times, and then you replace it. So we keeping it back in. So it's not like if we got a 1 once, then we won't get a 1 again ever, right? So let's generate it in R. So you can also type your code here. I was using the command prompt earlier, but I can do it right here as well. So the first vector is in, size is equal to 10, and replace is equal to true. Oh, again, always make sure you write true. That is caps lock, uppercase. So I got these outputs right here. That is 134, 1366, 354. Right. So I sampled it 10 times. Let's do something wherein I've written it as false. Replace is false. So here what we get is that we cannot take a sample larger than the population. So if I have 6 in the population, right? So 6 elements in the population, and I'm saying that I want to sample it 10 times, but then I'm not replacing it back in. So then after the 6th try, there would not be any elements left. So let's say, let's keep it as false, but let's keep the size as 6. So we want to like sample it 6 times. We get it, right? So that's like 352,164. So that's what happens. That is what sampling does. Next one is distributions, and I think this is a statistical course, so you should be aware of there are 4 types of distributions that we usually use for probability: Gaussian, Poisson, normal, and binomial. I think I think it will be covered during the lectures, so I won't go into the theory part of it due to time constraints. But all these 4 types of distributions will have 4 types of functions in R. The first one is a density function, a random number generator, cumulative distribution, and a quantile distribution, quantile function. So these 4 functions give you different forms of attributes of the distribution. And we'll be majorly looking at the random number generator because that's what we're looking at sampling. And our norm basically uses normal distributions for the random number generator. And let's use our norm once. Oh. So I sampled 10 values distributed between 0 and 1 using our norm 10, right? So now the next thing that we want to do is we want 10 values with at the mean 50 and standard deviation 10. The spread would be 10, right? Let's try that. So now the standard deviation was 50. Sorry, the mean was 50. It was around minus 10 and plus 10. Let's store it again as X, and we will find the summary of that. So again, we get the minimum, the first quartile, median, mean, third quartile, and max. Perfect. So that's sampling distributions. Again, so I was talking about seed setting. So that's what we do. We ensure reproducibility. Let's do this. I'll run our norm once. Let me just generate two values. All right. Now, what I'll do is I'll set the seed. Okay, I should have set the seed first earlier. Set seed r norm 2. I get these values. Now I run r norm again. I get two different values, right? Now I set the seed again. I should get the original value. So when I set the seed and I ran r norm, I got the same values, right? That is what you do, like you reproduce the same outputs again and again. Okay, now I don't think we need RStudio. Cool. Okay, so this is the second part. So I'll just stop the